Okay, good morning. Welcome to
KidMath55.
Sorry, I got a little cough. Unfortunately, I have to go to work early today, and double unluckiness. I got up super early today, but while I was tired and trying to think what to do before I went off to work, I came up with a really neat idea. We've been studying continued quadratic formula, and a long time ago we studied continued fractions, right? Mm-hmm. So does this look familiar to you?
Yes.
Yeah, so continued fractions are just a little bit different than normal fractions that you see, like, I don't know, 10 sevenths, in that they kind of go on forever. And they used to be studied a lot, and they're not really too much anymore, which is too bad because they're super cool. So let's just do a quick review. One of the things you can do to sort of get a feel for what your continued fraction looks like is just stop after a certain amount. So if on this one, if we just stop right at the beginning, we just get what? We ignore this whole rest of this thing.
We just get 1.
We just get 1. If we stop after 2 of these bottom terms, what do I get?
You get 2.
Okay, why?
You get 1 plus 1 over 1, which is just 1 plus 1.
Which is 2, right? Very good. Now if I stop after 3 of these bottom terms, now it gets a little bit more complicated.
Let's see, so this one doesn't matter. So you have
Wait,
1.
what? No, that's where we're stopping.
Yes, you have 1 plus 1, which is 2.
Oh, I see
1
what you're
plus a
saying.
half.
You have 1 plus 1 on the bottom because 1 over 1 is 1. I see. Sorry, I misunderstood. 1 plus a half. Now?
Or 3 halves.
3 halves. And we'll stop at this one now down here. So now it gets kind of.
So we have this is our, so we have 1 plus a half, 3 halves, flips upside down to become 2/3. 1 plus 2/3 is 5/3.
5/3. And if you continue this on forever, with this fraction, you start with 1 over 1, then you get 2 over 1. I'm writing those as fractions so you can see what the pattern becomes. Then you get 3 over 2, 5/3, 8/5, 13/8, and it goes on. And this pattern of the numbers in the bottom is what?
Fibonacci numbers.
It's the Fibonacci numbers, believe it or not. And on the top, what do you get?
You still get the Fibonacci numbers, but you need an extra 1.
That's right. You have the Fibonacci numbers on the top too, just shifted over 1. So somehow this relates to the Fibonacci numbers, which is really amazing, actually, isn't it? So just this simple continued fraction gives you the Fibonacci numbers, and that's really neat to study. But it also relates to a quadratic. And so we're going to actually today solve and tell what number this exactly is. And that number must relate to the Fibonacci numbers too somehow, right?
Yeah.
So the way we see that is we look at this fraction a little bit differently. Put on your look at it differently face. Very good. So what we're going to do is we're going to say x equals 1 plus 1 over 1 plus 1 over 1 plus 1 over 1 all the way down forever. Okay? And now I'm only going to look at this part of it here. Like that. So I'm going to ignore this part this time. So I'm going to look at everything that's underneath the first fraction bar.
Well,
what does that remind you of?
The same stuff up here. It's exactly the same.
Yeah, so when a piece of something equals something else, do you remember what sort of math that kind of is like, or does it remind you of something? Fractals. Sort of. This is sort of a fractal. But this bottom part here is just exactly the same as the whole thing. And what did we call the whole thing?
We called the whole thing x.
We called the whole thing x.
So it must mean x equals this part too.
Right, that's exactly right.
And you slice off this part, and it's still the same, so x equals that.
Yeah. But, let's stop it just at the very beginning. So this must mean that x equals 1 plus 1 over x. Right? Because that's what this part was. Now, how can I simplify this expression, this algebraic expression?
Well, you can multiply by x.
And what do I get?
And you get x squared is 2. No, x squared
equals
1 plus 1 over...
Be careful. Multiply the whole... When you multiply this side by x, I get x squared. What do I get when I multiply this side by...
x plus 1.
X plus 1. And this I can turn into what?
Can you turn this into a quadratic?
Well, it looks like a quadratic.
Yeah. Could you move the x... Well, actually, let's move this to the other side so we keep this.
And what do I get when I move this to the other side? I get x squared.
X squared minus x minus 1 equals 0.
Equals 0. Okay, now I'm going to erase my continued fraction. Okay. Okay, so we have our quadratic formula that says the solution to ax squared plus bx plus c. Do you remember what it is? What's the solution?
It's minus b
Yeah?
plus or minus the square root of b squared minus 4ac over 2a.
Over 2a. Okay. So a, and in this case, a is 1, b is minus 1, and
So
c
C.
is minus 1. Okay, so I get minus minus 1, which is 1 plus or minus the square root of,
Minus 1 squared, or I. Wait, no, that. The square root of b squared. Minus 1 squared is 1.
minus 1 squared is 1, right? Not the square root of it, the square. Minus 4 times a times c. What is minus 4 times a times c?
Well, a times c is minus 1.
Right?
So times minus 4 will just be plus 4.
Right? And the whole thing is divided by
2.
2. So I get 1 plus or minus the square root of 5 over 2 must be what our initial continued fraction equals. But this fraction probably isn't equal to the original fraction. Well, probably wasn't equal to 2 numbers, so we have to figure out which one of these it's equal to. Now, what is the square root of 5 approximately?
Well, it's a little bit more than 2.
Very good. So what can you tell me about 1 minus the square root of 5?
That's negative.
So do you think a number that we would write as 1 plus 1 over 1 plus 1 over 1 plus 1 over is going to be negative?
No.
No.
Because you have too many pluses.
Well, they're all positive numbers, right?
Yes.
So 1 plus the square root of 5 all over 2 is what that continued fraction equals. And this continued fraction here, this number, must somehow be related to the Fibonacci numbers.
1, 5, and 2.
3, 5, 8, 13. Well,
1, 2,
you're right.
and 5.
1, 2, and 5 are hiding in there. That's a good point. So we'll learn later why this is related to the Fibonacci numbers. Cool.
Cool.
Very cool. All right. Good job, sweetie. Good job.